like most things at National 5 Maths, non-rectangle trigonometry can be done with or without a calculator. 99% of the time, when you're working with one of the trig rules, you're going to be using a calculator. However, when you come across a situation where you've not got a calculator, so a non-calculator assessment, and you've been asked to do some trigonometry, don't panic, okay? What you need to remember, trigonometry is all about number work, okay? Now, the problem is, when you are dealing with trigonometry, you're dealing with loads of different possibilities of numbers. So remember, when you type in something in your calculator like the cosine of 20 degrees, your calculator is going to a big table like this, and it's going, the cosine of 20 degrees is this, and it spits out this result. So whenever you are using the sine, cosine, or tangent button on your calculator, all it is doing is looking up a number in a table like this that has been programmed into your calculator. Now, the numbers in that table were fairly awkward decimals. However, if you're being assessed on trigonometry in a non-calculator paper, the numbers are going to be rigged to be manageable without a calculator. Here, we've got an example of in triangle ABC, we've got AB is 4 units, AC is 5 units, and BC is 6 units, and we have been told to show that the cosine of A is equal to 1/8. So notice this is the cosine of A. We've not actually been asked to find the angle A, we've been asked to find the cosine of A. Right, I've just popped my wee formula list down here. We're actually quite lucky when we've been given a non-calculator question. One of the toughest bits of non-right angle trigonometry is picking the right rule from our list here. Here we've been told to find the cosine of A. So that is telling us straight away, use this rule. Let's just double check that's okay. We need the three sides, A, B and C. Well, we've got the three sides of this triangle, so we can use the cosine rule. Cosine of A equals B squared plus C squared minus A squared all over 2BC. Now remember, you're finding an angle, so this minus A squared will be the side opposite the angle we're trying to find. So I can just start substituting in the values now. The cosine of A equals B squared plus C squared. I suppose we could do this properly. If this is B, angle B, this 5 will be side B. 5 squared plus, there's angle C, so this is side C. 4 squared minus 6 squared. So just checking we've got that right. The A should be opposite the angle we're trying to find, and yep, we're in the right position. Right, all of that is over 2 times B, which was 5, times C, which was 4. Now, all we've really got left to do is some number work, okay? Every single piece of number work we've got here is more than appropriate for a National 5 level pupil. We've got to square a single digit number, and we've got to multiply by a single digit. You will then have a fraction to simplify. So all of this is totally appropriate, and if you're working at National 5, stuff like this should be a doddle. I wouldn't expect you to be able to do it all in a oneer, so you break it down and do it carefully. 5 squared plus 4 squared minus 6 squared. 2 times 5 times 4, well that'll be 10 times 4 is 40. We need to tidy up the top bit, so there is nothing wrong with doing little calculations at the side of your page. So I've got 11 2, 3, 4, so 41. 41 minus the 36 will give me 5. So I'm just going to move this up here. The cosine of A will be 5 over 40. We've got a fraction we can simplify by dividing the top and bottom by 5. So that gives me the cosine of A. 5 goes into 5 once, 5 goes into 40 8 times. Show that the cosine of A is 1/8. Cosine is A is 1/8 as required. So this is actually quite common here. Show that the cosine of A is 1/8. Sort of almost like a proof question. So it tells you the answer you are aiming for. Here we're in a slightly different position. We've been told in the triangle DEF, the sine of D, so we know the sine of this angle. We don't know this angle D, but we know the sine of it. So we know it's 4/5. The sine of F is 9/10, and EF is 4. Find the length of DE. So I just said on the previous page, you're often told what this is, and you've been asked to work to it. Here we've not been quite so lucky, but that's okay. Now, we have no way of actually knowing the size of these angles. Okay? If we had a calculator or a trig table, we could look up the size of the angle D and F by looking for these values in the table, or by doing the inverse sine of 4/5, the inverse sine of 9/10. But we don't actually need to use them. We know the sine of this angle and the sine of this angle. So this is telling us to use the sine rule. We have been asked to find DE. So that side I've marked with an X there. So this is clearly the sine rule, because this angle, this side, sorry, is opposite the angle we know the sine for. This side, we know, is opposite the angle we know the sine for. So the sine rule, so I've got these memorized, but you could be copying this from your formula list. A over sine A. Well, this is the side I'm trying to find, so let's call it X over, well, sine F. Sine F is 9/10. Right, B over sine B. We know this side, and we know the sine of this angle. So I'm going to have 4 over the sine of this. The sine of D is 4/5. Now, this is quite messy here. We've got fractions inside of fractions. What we need to remember, this, well, any fraction represents a division, okay? So I'm dividing by 9/10. I'm dividing by 4/5. I can actually rewrite this. Instead of dividing by a fraction, I can multiply by its reciprocal. Now remember, the reciprocal is the fraction flipped. So rather than dividing by 9/10, I can multiply by 10/9. Same thing over here. I've got 4. Now rather than dividing by 4/5, I can multiply by 5/4. I could tidy this up a little bit. 10x over 9 equals, now here I'm timesing 4 by 5, then dividing it by 4. So here, 4 divided by 4, that's going to cancel out, okay? 4 divided by 4 is going to cancel out and leave me with 1. So I'm just going to be left with one lot of 5 there. And I've got a really basic equation to solve. I'll get the 10x on its own by getting rid of the 9. So I can multiply each side here by 9. So timesing by 9 cancels out that dividing by 9. So 10x will be 5 nines is 45. I want to get rid of that 10, so I can divide by 10. You can either work with this as a fraction and simplify it, but here, 45 divided by 10, that's just going to be 4.5 units. You could have that as, let me think, that will divide both by 5. So you could have 9 over 2 units. But here, that's perfectly acceptable, but 45 divided by 10. It's probably easier just to go with a decimal there. There is an alternative way to deal with this. So here I used the reciprocal, so I multiplied by the reciprocal. What I could do is I could convert these to decimals. So what I'm going to do is I'm going to scoot over to the side here, and I'm going to go from this step and take a slightly different approach. So x divided by 9 over 5. Well, 9 over 10, sorry. That is just 0.9. 4 divided by 4 over 5, well, 4/5 is 0.8. Now, I'm looking at this. I could try simplifying this first. Now remember, simplify a fraction doesn't mean make smaller. To simplify means to actually make easier to work with. If I times the top and bottom of that fraction by 10, I'm not changing anything, but I'm making these numbers 10 times bigger. So this fraction is still the same as this. Now we've got something nice and easy to work with. 40 divided by 8. 40 divided by 8 is just 5. I could get the x on its own by getting rid of divided by 0.9. So I would multiply by 0.9. 5 times 9 is 45. So 5 times 0.9 will be 4.5 units. So 2 ways of doing this, either working with the fractions or converting to decimals. One more. Again, another sort of old exam question here. We've got a triangle PQR. We've been told PQ is 5 centimetres, QR is 7 centimetres, and cosine of Q. So we don't know this angle, but we know the cosine of it is 1/5. So again, just looking at this information, I'm pretty confident I'm going to be using the cosine rule here because the question's brought up cosine here. Calculate the length of the side PR. Calculate the length of this side here. So I'll put a wee x there. Leave your answer in the form the square root of a. So basically, we are going to, let's get started and then we'll deal with this. But it's saying, don't worry about taking the square root, just leave it in this format. Well, look at this way the question's set up. We've got two sides. We know the cosine of the contained angle. This is going to have to be the cosine rule. So if I pop my formula list over at the side here, to find a side, I need to know the other two sides, B and C, and if I'm finding something called A, I need to know the cosine of the angle contained, or opposite the side I'm trying to find. So we have to use the cosine rule. A squared equals B squared plus C squared. Well, let's write this down, plugging in our values. So A squared, so the side I'm trying to find is x squared, equals the other two sides squared and added, minus 2 times b times c, times the cosine of a. Now, I've just started writing, be very careful, I've just made a mistake here. It's very tempting to say it's the cosine of 1/5, and that's rubbish. The cosine of our angle, all of this thing here, is equal to 1/5. So we are saying the cosine of A, this is a number, and that number is 1/5. So I actually need to rub this out. The cosine of my angle is 1/5. Now I can start slogging my way through the number work. It's not that much of a slog because look, I'm squaring 5, I'm squaring 7, so again, perfectly reasonable number work to expect a National 5 pupil to be able to do. I can tidy this up in a number of ways. Whenever you're working with a fraction in a non-calculator question, the fraction will have been carefully picked. This 1/5 and the 5, these will actually cancel out. So 1/5 timesing by 5, then timesing by 1/5, that cancels out to give me the same as timesing by 1. So those two terms actually cancel out. And I'm left here with 2 times 7 is 14. I mean, if you didn't spot that, you would still end up with 14. 2 times 5 is 10, times 7 is 70, and then 1/5 of 70 is 14. But if you spot things like this earlier, go, what can I use this fraction for? Oh, I can use it to cancel down this a bit further. It'll make the number work a wee bit easier. Well, 25 plus 49, again, no shame in doing little scribbles like this at the side. So 14, 4, 5, 6, 7. So I've got x squared is 74 minus 14. So x squared will be 70 minus 10 is 60. All right, let's revisit this. This is x squared, but we want to find the actual side PQ. So x is the square root of 60. Now normally we should be looking at this going, how can I simplify this third? But it says, give your answer in the form square root of A. It doesn't want this simplified. It just says write it as the square root of something. So there we are. So just to wrap up, couple hints, couple tips. Look at the information you've been given. The information you've been given, or which trig ratio it mentions, is going to be a big hint as to which rule to work with. So here it's mentioned cosine, so I know I'm going to be using one of the versions of the cosine rule. If it said sine q here, that would be a big hint to use the sine rule. Then, look carefully and see what it is it's asking you to find. That'll help you narrow your choices down further. Any number work is going to be sort of a pre-National 5 level. Things like squaring single digits. The worst you're probably going to be asked to square is something like 11 or 12. The multiplication here, you're going to have to work with a fraction. You need to remember, multiplying by a fraction basically means find 1/5 of. You're multiplying by something like 4 over 5, it means find 4/5 of. Divide by 5 times by 4. Okay, so the number work is going to be straightforwards, and the question will give you a hint as to which rule you should be using.